Welcome to another Hoopo video. Today we're doing a quick paper deep dive. So if you're new to this channel, uh, these are quick paper dives. So we're only allowed to look at the abstract and the figures, and we're really trying to get this done as quickly as possible. No deep dives. If you guys are interested in paper deep dives, we also do these on this channel, but those take over 2 hours, much longer. You should definitely check them out. But this is for the people with shorter attention spans. So this paper, Visual ChatGPT, Talking, Drawing, and Editing with Visual Foundation Models, coming out of Microsoft Research Asia. This is a relatively recent paper, 8th of March, 2023. And let's get to it. The abstract. ChatGPT is attracting a cross-field interest as it provides a language interface with remarkable conversational competency and reasoning capabilities across many domains. Underrated, right? GPT knows everything. Anything that has text on the internet, GPT knows about it. Since ChatGPT is trained with languages, it is currently not capable of processing or generating images from the visual world. ChatGPT is a large language model, so therefore it is really only capable of consuming sequences of text, where the text is represented as tokens, which are, you can think of it as words, and it produces words or tokens, right? So it can basically only take text and respond with text because that's what it's been trained on, and that's kind of the modality that the architecture behind LLM was designed for. At the same time, visual foundation models such as visual transformers are stable diffusion. So transformer is a type of model architecture that is specifically designed for sequences and was designed for natural language processing. But since then, transformers have become really popular in other domains, and visual transformers is the application of transformers to images. And the way that it actually works is an image will be cut into these little patches, right? And then each of those little patches will be fed into first in some kind of encoder, but the transformer itself will see these little patches as if they were a sentence. Stable diffusion, of course, you probably already know what that is, but that's a diffusion model, so different from a transformer model. And it basically iteratively removes noise and in that way can kind of create images out of nothing. Both of these are big, popular vision foundation models. I don't know if I would necessarily use the word foundation model to describe vision transformers. I think visual transformers are a model architecture, but a foundation model that uses vision transformers would be something like CLIP. Although showing great visual understanding and generation capabilities, they're only experts on specific tasks with one round fixed inputs and outputs. Yeah, so much like LLMs are limited to language, vision transformers and stable diffusion are limited to basically generating images, although stable diffusion, of course, can take text prompts and perform generative diffusion with the text as a kind of guidance, or it uses the text to condition the generation of the image. So there is a couple modalities already involved in things such as stable diffusion and CLIP. To this end, we build a system called Visual ChatGPT, incorporating different foundation model to enable a user to interact with ChatGPT by sending and receiving not only language but also images, and providing complex visual questions or visual editing instructions that require the collaboration of multiple AI models with multiple steps. So I think this is the important part here. We're not going to be seeing a multimodal LLM. What we're likely going to be seeing here is a kind of more like a tool former, where a LLM has the capability of calling external models, right? Calling in the sense that you would call a function, right? Or the way that Toolformer would use a calculator tool. So in a very similar way, I think what they're going to do is they're going to basically give ChatGPT, the LLM, the ability to use image modality specific models. We design a series of prompts to inject the visual model information into ChatGPT, considering models of multiple inputs and outputs and models that require visual feedback. Experiments show that Visual ChatGPT opens the door to investigating the visual roles of ChatGPT with the help of visual foundation models. Okay, cool. So let's look at figure 1, the architecture of Visual ChatGPT. So user query. So this is what you would basically type into the ChatGPT box, right? And this is what the LLM is consuming. So the LLM is only really going to be consuming this text part, but it seems like they've also inputted in an image. right? So the LLM is not actually seeing that image. What it's probably only seeing is a link to an image. It's saying, hey, here's a link to an image, and that automatically tells ChatGPT that it's going to have to feed that into some specific model, which you can see here. They have Blip, Stable Diffusion. Blip is image captioning, so basically it's a model that takes images and produces captions for it. Stable Diffusion, which everybody really knows, is a diffusion model that can generate images given text. Pix to Pix is kind of like a Stable Diffusion, but basically you give it an image and a text, and it'll convert. It'll create a new image for you that's kind of similar to the original image. ControlNet is also a diffusion model. Specifically, it's a technique where you have this diffusion model that's kind of constrained by something like an edge image, which is produced from a canny edge detector, but also depth images, pose images, which are all also produced from pose networks and depth networks. So there's a lot of different subcomponents for even these visual foundation models. ControlNet uses a bunch of submodels itself. And object detection, of course, is a very classic computer vision problem, and there's all kinds of detection models that you could get off the internet. YOLO is a famous one. So you have kind of this palette of visual foundation models that are available to ChatGPT, the LLM, in kind of a tool former way. So you can see here how the user queries generate a red flower. Here's an image. Actually, you're not only saying generate a red flower, but you're saying conditioned on the predicted depth of this image and then make it into a cartoon. So once you feed this, there's kind of this notion of a prompt manager. This is probably what this paper is really all about. Is they're probably you're seeing these papers kind of come out more and more, where basically prompt engineering is becoming more and more intense, I guess, more involved. People are figuring out how to actually do prompt engineering, and I bet you that basically the prompt manager sees things such as conditioned on predicted depth, which to me means ControlNet. So it's going to be using ControlNet. It's first going to feed this image. It's going to get into a monocular depth estimation model. That's going to create a depth image, and then make it like a cartoon, right? Make it like a cartoon. Cartoon is going to become the text that you condition the Stable Diffusion model in addition with the depth image. And that Stable Diffusion model is part of a control net. That control net will output basically this image, but it looks red, right? And that, here you go, actually, here we go. This is the depth image here. This is the image that comes out of ControlNet, I suppose. And then maybe they use Pix to Pix here to convert this image into a cartoon style. So maybe there's also Pix to Pix happening here. And you can see here there's arrow flows that show that maybe this step-by-step implies that there's kind of intermediate steps here, which means that maybe it's not one inference in total. Maybe there's multiple inferences happening with ChatGPT, and all of that might be internal, hidden from the user. And then finally, you have the output, which is here, which is a multimodal output. So you gave this whole system of visual ChatGPT, you gave it a multimodal input and a multimodal output, and it has access to all these different tools, right? Very tool formery. All right, let's scroll. What do we got here? Overview of visual ChatGPT. The left side shows a 3-round dialogue. The middle side, so 3-round basically means there's 3 rounds of back and forth. One user, visual ChatGPT, user, visual ChatGPT, user, visual ChatGPT. The middle side shows the flowchart of how visual ChatGPT iteratively invokes visual foundation models and provides answers. So iteratively invokes visual foundation models, right? This concept of being able to externally call a different model and provide answers. The right side shows the detailed process of the second QA. Okay. So the user starts, they pose some question, and that question is merely, here is an image, right? And ChatGPT says, okay, I got this image. ChatGPT is not actually consuming that image. It's important. To ChatGPT, the only thing it really sees is this .png. It just sees a bunch of text that looks like the name of an image file. Then the user says, replace the sofa in this image with a desk and then make it like a watercolor painting. Okay, so Visual ChatGPT then says, okay, I need to use my little palette of tools that I have of my vision foundation models. How am I going to do that? So it goes and there's a little arrow that comes out here, and then it says user query QI. So QI, the user query, is going to be basically Q1 and Q2 here. So there's some index here to denote how which question along this conversation it is. You have your prompt manager M. You have a history of dialogue H less than I. So here it means there's less dialogue history than there is user queries. And then system principles P. So this is probably some prompt that has been engineered for Visual ChatGPT that allows this request to be fulfilled properly, right? So you have the foundation models themselves as well here. And the prompt manager M is going to craft the right response here. So determine one, use VFM. So I guess the first thing it needs to do is, hey, given this query, given this history of dialogue, given this palette of visual foundation models that you can use as tools, given your system principles, which is basically just a bunch of text that some engineer wrote that basically creates this question such that it can be answered by an LLM. And we don't know what A is here. I guess A here is the answer. So previous answers. Feed that into the prompt manager, which goes into ChatGPT. You ask it, use vision foundation models. It's going to say, yes, this is the type of question that I want to be able to use my visual foundation models for. Okay, then execute one, replace something from the photo. Okay, replace something from the photo. And then that is an actual command that you can then execute with the visual foundation model. So likely what's going to happen here, you see here a tuple, you have the image itself, you have a sofa, which is a text, and then desk, which is a test. So likely what it's going to be doing is it's going to run this image through an object detector, see if any of the output classes, right, any of the objects correspond to sofa. If that's the case, probably mask out that part of the image and then use something like a stable diffusion to fill in the missing pixels. So there's a lot of different hyperparameters here probably, right? Because anytime you use an object detector, there's going to be a threshold of confidence. There's potentially fuzzy matching. So the object detector might not use the word sofa. It might actually, the category or the class in the classification problem that the object detector has been trained on, it might use the word couch. So maybe there's some kind of fuzzy matching there where sofa and couch are very similar-ish words, but the devil's in the details, right? So there's likely a lot of little hard-coded parameters here in these visual foundation models and these tools that the LLM is using to solve this. Okay, so that gives you an intermediate answer. And that intermediate answer is a link to another image. And in this image, this is probably the output of this call here, right? So then once you have the output of that call there, which is just an image, you now have updated the history, right? So now the history of dialogue is updated. The query is the same. The system principles are the same. The visual foundation models are the same. But the answer is different here, right? This is intermediate answer 1, intermediate answer 2. So ChatGPT does have that in the context here, the prompt manager. And then it gets asked the question again, use VFM again. And it says, yes, I still need to do more. Okay, so then instruct image using text. Okay, so then now it's going to use a different vision foundation model. Likely now it's using pix-to-pix, and it's going to get a link to the previous image, and then it's going to get the text that it will condition the pix-to-pix model on. And that pix-to-pix model will take this text and it will condition a diffusion model to basically add some noise to this image and then remove the noise from that image such that it is now like a watercolor painting. And that vision foundation model function returns a new link to a new image. Intermediate answer 3. And that image is then fed again along with all these other things that we've been feeding into the prompt manager, which then goes into ChatGPT and it says, okay, do I need to use another tool? And it says, no, you're good this time. So likely all of this stuff here, all these intermediate answers are hidden from the user. So the user does not actually get to see that. As far as the user is concerned, they only see the final answer here, right? So prompt manager M, ChatGPT, use VFM, no. Once you get this no, right, then it'll just output to the user. But if you get a yes, then it basically keeps going into this loop, right, where it runs the tools or the vision foundation models that it has access to. Then it creates these intermediate answers, adds to this history of reasoning, and then goes all the way back to the prompt manager. So important to note here that the prompt manager is basically a bunch of hard-coded logic. And much like how we saw basically over the past, you can almost say 100 years, but more like 50 years, right? Programming has gotten increasingly easier and easier, right? You had kind of Fortran and very complicated languages that were very close to the hardware. Then you had kind of increasingly more and more high level, more abstract languages until finally now you have things like Python, which are very easy to read, very high level, almost read like text, right? And it seems like here what we're seeing with these prompt managers and system principles is like we're basically creating this kind of prompt engineering language now where the way that you program specific behaviors into computational systems is with text now, right? So that's something cool to think about. But yeah, that's largely it for this figure. And I suspect this is very, very similar to what they're going to be doing for GPT-4, which I have heard is supposed to be multimodal, is probably going to be something like this. I'd be curious what they use, right? Because the way that this paper is framed, not all of these are OpenAI models, right? ControlNet, Stable Diffusion. ControlNet uses Stable Diffusion. Detection, right? You could use YOLO, but that's not an OpenAI model. You could use Detectron 2, but that's a Facebook repo, right? So these vision foundational models, these are not all created by OpenAI. So I'd be curious to see if ChatGPT 4, which supposedly is supposed to be multimodal, will use external models that are not created by OpenAI, or whether OpenAI is going to want to have their entire suite of models that is all in-house, right? They're going to want to have their own canny edge detector, their own pose model, their own diffusion model, their own pix-to-pix. Seems like a lot of overhead for them to do, a lot of engineering and developer time to create their own versions of all these models. So I'll be curious to see what they do. All right, we got another figure here. Figure 3, overview of the prompt manager. This is the hard-coded logic that we were talking about. It converts all non-language signals into language so that ChatGPT can understand. So it converts all non-language signals into language. So, right, ChatGPT, being a large language model, can only consume text, right? It cannot consume any other type of image modality. So any type of image needs to be, or non-language signal needs to convert into language so that ChatGPT can answer it. System principles. We got our prompt manager MP. Access to VFM. Visual ChatGPT can invoke different VSMs to indirectly understand pictures, right? So it can call external functions. Visual ChatGPT is very strict to the file name and will never fabricate non-existent files. So ChatGPT, you don't want it to see a file name as a sequence of tokens that it has to generate every time, right? GPT generates answers token by token. If your file name is made up of like 10 different tokens, it might not get it perfectly right every time. So there's probably some hard-coded logic that makes the file name basically like a single token as far as ChatGPT is concerned, such that it always, or it might not even be converting it into a token. It might just like have hard-coded logic that very precisely puts that exact file name in there so that you never get this issue where ChatGPT maybe gets little individual parts of the file name wrong. Reasoning format and PNG here, this is a image format. PNG is an uncompressed image format, so unlike JPEG, it does not lose information. Reasoning format, thought, do I need to use a tool? Yes, the action to take should be one of tool names, the input to the action. Okay, so ChatGPT is going to be answering the question of, hey, given this prompt, do I need to use a tool? Likely it's been fine-tuned on a bunch of examples of this, is my guess. Action, so this is what you want the actual, what function do you actually need to use to be able to perform this action, right? And there's going to be some set of tool names such as Stable Diffusion, Pix2Pix, and so on. And then the input to the action, right? So each of these actions, each of these VFMs is going to have, it's kind of like a function. It's going to have different arguments that you need to pass to it. And the ordering of those arguments needs to be precise, and the exact format of that argument needs to be those arguments needs to be very precise. So that's why you need to be very careful here. Okay. Well, that seems to be going into ChatGPT here. Then we have VFMS document. Okay, blip VQA, Pix2Pix, these are different image models. Name, usage, input, output. Okay, so what's happening here is that basically you need to basically almost create like a data sheet, right? You need to create a kind of like a data sheet and a kind of like instruction manual that lets ChatGPT know exactly what each of these models does and what it can be used for and what the specific input and outputs of this are, right? So we don't know exactly how these are fed into ChatGPT. I think it's likely as an example. So this is probably either fine-tuned for this, or more likely than not, it's basically just some prompt engineering. Some in-context learning is another kind of terminology for this. So something like this, the blip VQA, right? Blip is a image captioning model. So VQA, visual question answering, right? You give it a image and then you can get the caption, or you can answer specific questions associated with that. Useful for when you need an answer for a question. Last input to this tool should be a comma-separated string of 2 representing the image path in the question. There's likely additional kind of testing being done that's done in code to make sure that any function call that ChatGPT generates is precise and exact. Similar type of thing here. Pix2Pix allows you to kind of convert an image into a different style. Okay, you have a history of dialogue. This basically just means that keeping track of all the different stuff that you've sent to ChatGPT, and by keeping track of that and feeding it in every time, ChatGPT can better help, right? User query QI. Visual generates a unique file name with a universally unique identifier. Okay, so this is maybe what we were getting at before, where it maybe converts the file name into a specific token, and then it keeps track of kind of a dictionary of that specific token and that specific file name. Because not only like these type of tools, right? These type of blip VQA, Pix2Pix, these functions require loading an external model into memory, potentially calling a model API, some kind of model serving, and passing things around. So like not only does ChatGPT need access to each of these models, likely via some kind of API, but it also needs, it's going to perform a bunch of calls that are actually doing things within the file system, right? It's actually going to be passing files or potentially sending files, such as images, receiving files such as images, potentially renaming things. So there's a little bit of tricky file system stuff that it needs to do there too. VFM executes prompt manager. Claimed chain file name, a unique ID, the operation, previous name, original name. So this is more kind of hard-coded stuff here. The user's command is ambiguous. Visual ChatGPT should ask the users for more detail. Okay, so then there's some notion of like, hey, if the question that you've received or if the history of dialogue makes you think that the answer to this question of do I need to use a tool is a little bit unclear, then ask for more detail, right? So it's important to note that this is not, if you're using Visual ChatGPT and it says, hey, I don't really understand, can you help me understand that more? It's not ChatGPT coming to the conclusion that it needs to know that, right? It's been basically told specifically by the prompt manager to do that. So this is like all hard coded, right? Right, table 1 foundation model supported. So these are different image models that it has. So image to text, this is blip. Image to edge, canny edge detection. You have HED, line, segmentation. These are other things that generally get fed into a control net. Depth maps, normal maps, sketch and pose. These are all control net inputs. Pose to image, sketch. So these are all the control net outputs. Image question answering. This is also not necessarily correct, right? The way control net's going to work, you first have a model that goes from your model into something like an edge image, but then the edge image gets fed along with text to create an image. So this really should say edge plus text to image, line plus text to image, and so on. Remove objects from image. This is an object detector with probably some masking logic. Replace objects from image, similar kind of thing. In painting with a stable diffusion. Change image by to text. It's basically just a superset of these two functions. Image question answering, probably also some combination of blip. But again, all of these functions are basically hard-coded logic. These are like written by an actual human. So the tools that the LLM uses are not written by the LLM. They're hard-coded functions created by a human programmer that have very specific inputs and outputs and need to be very specific in terms of the format of each of those inputs, the ordering of each of those inputs, and so on. Experiments, setting. They have some GitHubs for different projects here. ControlNet. I wonder if they're actually using the Hugging Face ControlNet. And then here are some examples. All right, let's look at these ones here. Case study of prompt managing of system principles. We qualitatively analyze the 4 proposals: file name sensitivity, reasoning, format strictness, reliability, and chain of thoughts. The top left shows whether emphasizing the file name sensitivity and MOP. So this is the prompt. Back the file reference accuracy. Further parsing cannot be performed from the top right points without reasoning format strictness. The bottom left shows the difference between whether to tell ChatGPT to be loyal to observation rather than faking image content. Okay, so let's see. Okay, so the user puts an image. ChatGPT says received. It says generate a figure of a lovely cat. Okay, and I guess that the way that the user question or set this text, it doesn't really imply that you want it to be different from this image. So this just calls probably stable diffusion and just uses that text to generate an image. And then it says generate the depth image from the figure I gave you. Okay, so here's the rub. Here, by considering the file name sensitivity, so here it's been able to basically say the figure I gave you corresponds exactly to this one here, which means that whenever you say give me the depth image, I'm going to give you the depth image for this exact image here, which is what you see there. But here, without this file name sensitivity, right, without this kind of like hard coding of this directly corresponds to this, what ChatGPT is going to do is it's just going to generate a depth image from this image here, and that's not what you want. All right, reasoning format strictness. Can you generate a Chinese water ink painting of a landscape? Can you generate a Chinese water ink painting of a landscape? Sure, I have a generated Chinese water ink painting of a landscape. Here you go. Yes, Visual ChatGPT needs to use a tool to generate a Chinese water ink painting of a landscape. We'll use a generate image from user input text tool to generate the image. The output for this tool should be Chinese water ink. Visual ChatGPT will generate a file and provide. Failed to start reasoning. Reasoning format strictness. Okay, so I guess this is almost like an ablation study, it seems. So basically they're showing you how these different failure cases arise when they don't have these specific concepts within the M of P, which if we scroll up here, M of P is the prompt manager. So the prompt manager, of course, is the human designed kind of logic that determines this type of stuff here, right? Where what specific files are using, all the file system stuff is all hard coded with this prompt manager. When exactly it should be calling and using tools, right here, the reason it fails is because it doesn't actually it doesn't use the tool. It just kind of like goes off and describes what it would do, but here it actually does use the tool. Reliability. Can you tell me something about sunflowers? Okay, so here, considering reliability, maybe this is why they include the history. So I think in the previous image, they show that they have like a history of the conversation. Maybe here they show you that without the history, right? Initially it's talking about sunflowers and now it's talking about roses. So it gets confused, kind of loses track of what's going on. So by, I guess, explicitly providing the history, does not make that mistake. And again, these are my guesses. I haven't read this paper, right? I'm trying to do a quick summary, which means that you can kind of tell some things by looking at the figures, but sometimes you don't really know. So this is my guess, is that this is showing you why they do the history. Chain of thought, draw a big figure of an apple, then use a pear. Okay, so here, chain of thought, I think what they're referring to here is whenever you, a trick that someone came up with in the prompt engineering world a while ago was, for example, using the words step by step, like think step by step. And that forces the large language model to basically not just jump to the final answer, but try to come up with a set of steps which get you to that final answer. And that chain of thought reasoning showed to be pretty useful in things like math problems and arithmetic. And it seems like here they realize, okay, why don't we apply this same trick to this visual ChatGPT and see if it makes it better. And when you use chain of thought reasoning for visual ChatGPT, you can see here how first it realizes, okay, well, I don't have a picture of an apple, so let me first generate a picture of an apple with my Stable Diffusion tool. And then I'm going to take that picture of an apple and I'm going to use my object detector and my mask in painting to replace the picture of an apple with a pear. Versus if you don't have the chain of thought reasoning, what the large language model is going to do is it's going to say, okay, well, I'm going to replace the apple with a pear, and then it's going to be like, wait a second, I don't have this apple.png, and it fails. Right, so very sensitive to the tools, right? The tools need to be perfect. If you ask it to do the object detection and mask filling task, but you don't actually give it an image, it's just going to hard fail. Case study of prompt managing of foundational models. We qualitatively analyze 4 proposals: name, usage, inputs, outputs. An example: the top left shows that Visual ChatGPT will guess the tool name and then fails to use the correct tool without the tool name. The top right shows that when the usage of the tool name is missing or unclear, it will call other tools or encounter an error. Yeah, so This is not great, right? Basically, like ChatGPT is like a fuzzy answer, right? It's not these the prompt manager and this whole visual ChatGPT system. There's hard-coded logic created by humans that has these functions that are very, very sensitive to the input and output. So, and they're probably sensitive to the type of tool. I use the tool to predict depth. Depth detection on image is not a valid tool. So, can you predict the depth image? Can you predict the depth image? It's basically it knows that it has to do depth, but here it's calling it depth detection, which is incorrect, right? What it should have called is like the depth tool, which is probably not called depth prediction or depth detection. So here it's like it's using the wrong name for a tool, so it can't find the tool, so it errors out. So having it choose explicitly from a list of enumerated tools is probably how they answer here. This is the name of the tool. The usage of the tool, this is probably just making the actual function call, right, correct. So making sure you have the file name and then whatever other extra things you need. Inputs and outputs, I think that's the same kind of idea. Make sure you have the right uh, image. And then example, what is going on here? Without example of foundational model, by adding example of foundational model. Okay, so maybe they provide examples, and then this is what you get better results when you provide examples. Generate chained file name. Okay, so that's some kind of like internal naming scheme for the images. Case study of prompt managing of the user query, model output, qualitatively analyze the four proposals, unique file names, force VFM thinking, visual foundation model thinking, chained file names, and ask for more details. Unique file names avoid overwriting, right? Because it has access to a file system, basically. Top right shows force VFM thinking encourages tool invoking in strict thinking format. Bottom left shows chain file naming helps understand files and can be successfully observed and concluded by visual ChatGPT. The bottom right shows visual ChatGPT is able to detect ambiguous references and ask for more details. Okay, so here in this bottom one, you give it an image, it says received, replace the cup with a fruit, and it says please specify which cup. So replace the cup with a fruit, it's going to be calling its object detector. The object detector will have some hard-coded threshold, and it'll produce 3 bounding boxes of 3 cups. And because the confidence on those 3 cups and the overlap of those 3 cups is sufficiently low, I guess, it's going to ask you. Like, this seems like this is pretty hard-coded, right? Like, if this cup had a confidence of 99 in the object detector and these two had a confidence of 20%, would it still ask this question? I don't know. If this was glass, maybe there was a different word that was used in the object detector classification part, and it was like a glass or container or something like that, and then this one was cup, would it still ask that question? So a lot of hard-coded logic probably that goes from this to this. Case study conclusion. Okay. In this work, we incorporate Visual ChatGPT, an open system incorporating different VFMs and enabling users to interact with ChatGPT beyond language format. To build such a system, we meticulously design a series of prompts to help inject the visual information into ChatGPT, which thus can solve the complex visual questions step by step. Massive experiments and selected cases have demonstrated the great potential and competence for different tasks. Some generation results are unsatisfied, and the instability of the prompt. One self-correction is necessary for checking the consistency between execution results. Human interactions according making the corresponding editing. such as self-correction behavior can lead to more complex thinking of the model, significantly increasing the inference time. Yeah, so the increased inference time is definitely something to think about, right? So in these kind of systems here, right, you're no longer just performing inference on a model, right? Like when you talk to ChatGPT, all you're doing is just you're performing inference on the model. It just keeps predicting token by token. But here, and this is something we saw with Toolformer as well, it has to go out and do these external calls, right? So the ChatGPT has to, you ask it a question, then it pauses, it calls an external API, gets the depth image, or sends the image, gets the depth image, then does probably a bunch of internal kind of intermediate question answers, right? So here you have 3 different inferences, and each of these inferences themselves have 3 different external function calls, right? You have an external function call to an object detection model, and even this one here is 2 different function calls, right? It's a detection model function call, and then it's image in painting. So 2 different function calls here, 1 different function call here, a pix to pix. So if you're the user, like this might take 20 seconds, right? And you're just sitting there for 20 seconds waiting for ChatGPT to come here, right? So the inference time, if ChatGPT can use a bunch of external tools, can get kind of out of control pretty quickly. So I wonder how, from a user experience standpoint, they'll look to solve that issue. The other issue I kind of see long term with these things is the hyperparameters. I think that these type of models, such as Stable Diffusion, ControlNet, detection models, Pix2Pix, all of these have hyperparameters, and it's not immediately clear how the user would specify or even know what hyperparameters to use for these, right? And I'm sure they'll choose kind of sensible defaults, but I wonder how they'll solve that, right? I wonder if they'll allow you to say things such as, hey, generate a red flower conditioned on the predicted depth, but I want you to use this particular guidance weight when you're using the control net, right? Like if you do that, now they have to have all this hard-coded logic to say, okay, if we see the user say guidance weight, we have to then take that number and then make sure that it's within 0 to 1 and it's a float and it works fine. So you can see how if you start to account for all the hyperparameters that you're going to need for these visual foundation models, the prompt manager can get very, very complicated very, very quickly. It can almost start to look like a expert systems style AI from like the 80s and 90s when people had these very, very complicated, basically one kind of way to describe expert systems is this giant if else statement, right? Like millions of little ifs, elses, and ifs, elses. And that's not being nice to them, of course. That's kind of tongue in cheek, but any kind of hard coded human logic is going to require that kind of stuff, and it's going to eventually become that. So curious how they solve that. Cool. Visual ChatGPT, probably actually a preview of what we're going to see with ChatGPT 4, which the rumor says is multimodal. So see what that is. We're a little bit over, but we made it underneath 45 minutes. So if you liked this kind of faster paper summary, let me know. If not, definitely feel free to jump into our live deep dives where we actually spend the whole time to read the paper. And if you have any paper recommendations, feel free to go on the Discord for this channel and chat to us and give us some recommendations, and maybe your paper will be presented. If not, like and subscribe. Thank you for listening, and talk to you guys later.